Bright Duty. Every student matters.
Hello children, welcome to the session. In this session, we are going to discuss about a few question and answers from the topics that we have covered so far. So children, the first question is, what are electromagnets? So children, electromagnets are the temporary magnets which we create using the magnetic effect of electric current. Okay, understood? So the magnets which we create using the magnetic effect of electric current are known as the electromagnets. Okay. So let's move to the next question, which is, give two methods by which we can increase the strength of a magnetic field produced by a circular coil carrying current. So children, you have to suggest a few ways in which you can increase the magnetic strength of the electric coil that we are using, okay, which is carrying the current. So the first way is by increasing the amount of current passing through it. If you increase the amount of current passing through it, the magnetic strength will also increase. And second is by increasing the number of turns. As you will increase the number of turns, the magnetic field created will also be increased. Okay, so the two ways to increase the magnetic strength are by increasing the amount of current flowing through the coil, and second is by increasing the number of turns of the coil. Okay, so let's move to the next question, which is, what are the uses of electromagnet? So children, what are the uses of electromagnets? So children, the first use of electromagnet is that electromagnets are used in hospitals for treating any eye injuries, wherein we require to remove the eye splinters from the eyes. Okay, so it is used in hospitals. Second, it is used in the cranes in steelworks or scrap yards for lifting heavy loads in the iron containers. Okay children, so it can be used to lift the heavy loads using the iron containers. Okay, and also it can be used to separate the iron articles from a lot of junk, if we need to separate the iron articles. Okay, so in that case also we can use the powerful electromagnets. Then the next, it is also used in loudspeakers. In telephones, the receiver of the telephone contains electromagnet, children. Okay, then it is also used in relays. Relays are electrically operated switches. Okay children, and some relays use electromagnets to control the operation of a switch. Okay, and also it was some of the first computers used relays. Also children, the electric motors use the electromagnets. Motors use electromagnets which find wide applications in electric fans, washing machines and refrigerators. So these are some of the uses of electromagnets. Okay children, so let's move to the next question. The next question is, are electromagnets permanent? No children, the electromagnets are not permanent. They are temporary magnets. They behave like a magnet only till the period, only till the time the current is flowing through the coil. Okay, and once you switch off the circuit, switch off the key, the current will not flow through the coil and it will not behave like a magnet. Okay. Next question, give the name of any two electrical appliances in which electromagnets are used. So children, electromagnets are used in your telephones, and it is also used in refrigerators, and I am sure you can refrigerators. And I am sure children, you can name many appliances from around you wherein we use electromagnets. These are just two examples. Okay. So the next question is, children, Paheli does not have a night lamp in her room. She covered the bulb of her room with a towel in the night to get the dim light. Has she done the right step? Give one reason to justify your answer. So children, what Paheli did was, she covered the bulb with a towel. So has she taken the right step, children? No, she has not taken the right step, children. Why? Because if the bulb will remain on for say a lot of time, say for a period of 2-3 hours, what will happen? It will produce heat energy, because we have studied about the heating effect of electric current. Whenever the current is flowing through the bulb, it is glowing and it will produce heat energy. And if you place a towel or any cloth for that matter over this bulb, it can catch fire. So you should never do this. Okay children, be very careful around the electrical appliances. Okay, so let's move to the next question. The nails attract pins. Comment. So children, the simple iron nail, if you have a simple iron nail, can this nail attract pins? Safety pins or paper pins, can it attract pins? No, definitely not. It cannot attract pins. But what we can do to make it attract any pins? We can convert this iron nail into an electromagnet. We can make it a electromagnet by coiling it with a wire and connecting it to a circuit and completing the circuit, and when the current will flow through the wire, it will start behaving like a magnet, and only then this iron nail will be able to attract pins, otherwise not. Okay, and children, just use your common sense, just use the concept that you have understood, because these type of questions can come up to 3 marks. Okay, and if you are clear with the concept, I'm sure you will be able to answer these. Okay, then the next question is, if the current flows through the coil, stops flowing. So we have this coil and the current stops flowing through it. Will it still remain an electromagnet? No children, this is a temporary magnet and it will behave like a magnet only till the time the current is flowing through it. And the moment the current stops flowing through it, it will not behave like an electromagnet. Okay, clear? The next question is, name 2 electrical devices where heating effect of current is used, and second where the magnetic effect of current is used. So children, what was the heating effect of electric current? Heating effect of electric current was whenever current passes through a conductor, it produces heat, and this effect was known as heating effect of electric current. And the devices which use this principle are geyser, electric iron, and you can name many other, but in this question only 2 devices are asked. Okay, and what is magnetic effect? It is the effect, suppose in this wire the current is flowing, so there will be a production of it will start behaving like a magnet. And how we can verify this? We can verify this by placing a compass near it, and it will show a deflection which indicates that whenever a current is flowing through this wire, it is behaving like a magnet. So children, what are the devices? Devices can be loudspeakers or refrigerators. Okay children, and I'm sure you can write many other examples that we have already discussed in the session. Okay, so let's move to the next question. Electromagnets are better than permanent magnets. Why? So children, electromagnets are actually better than permanent magnets. Why? Because we can switch it on, we can switch it off as per our convenience. Okay, so that is why the electromagnets are much better than the permanent magnets. Okay, so next question is, if the current flows through a wire, does the wire behave like a magnet? Yes children, if the current is flowing through a wire, will it behave like a magnet? Yes, it will start behaving like a magnet. And how we can verify it? We can verify it by bringing a compass near it, and when the current will flow through the wire, this needle will show a deflection indicating that the wire has started behaving like a magnet. So let's move to the next question. Question is, what is the principle of electric bell? So children, an electric bell is based on the principle of magnetic effect of electric current. Right? And what is the magnetic effect of electric current? So children, whenever a current flows through a coil or a wire, this wire will start behaving like a magnet. It will be a temporary magnet which will behave like a magnet only till the time the current is flowing through it, and as soon as we will switch off the circuit and the current stops flowing through it, it will not behave like a magnet anymore, and we call it as an electromagnet. Okay, and how we can verify this magnetic effect? By placing a compass over here, and whenever the current will flow, this needle will show a deflection indicating the magnetic effect of electric current. And children, we use this principle in case of an electric bell. Okay, so let's move to the next question. Give the mechanism of an electric bell. So children, in order to understand the electric bell in detail, this is a very important concept. This can come in exams. So you will have to give all the materials required. You have to give the aim, you have to give the mechanism, you have to give its construction. Okay children, so let us discuss about everything, the setup and the procedure. So children, we have a gong which is made up of metal, which produces the ringing sound when this hammer will hit. Okay, and this hammer hits this gong and produces the ringing sound. Then here we have created an electromagnet which is connected and we have connected it to a cell and a switch. Okay children, and we can observe it through this diagram, which is relatively simpler. So this is the switch button, and let us first discuss about its setup. We have this switch which is connected through this wire, and we have coiled this wire over this soft iron piece, and you can observe the coiling over here, right? And this is connected to a screw over here, and we have this metal plate, and to this metal plate we have an attached hammer, and here we have a gong. Okay children, here we have a gong. So whenever children we push this button, what we are doing? We are completing the circuit, and as a result the current will start flowing through this wire. And when the current starts flowing through this wire, this soft iron will start behaving like an electromagnet. And once it starts behaving like an electromagnet, it will attract this metal plate towards it, and to this, suppose this is a metal plate, and to this metal plate, what is attached to this metal plate? We have a hammer which is attached to it like this. And when the metal plate moves forward, the hammer is also moving along with it, and it will hit the gong like this, and it will produce the ringing sound. So this is the complete principle of this electric bell. And children, when we switch it off, that is we when we stop pressing it, the circuit will break, the current will no longer flow through this wire. As a result, this wire will not behave like an electromagnet, and it will no longer attract this metal strip, and metal strip will return to its initial position, and along with the metal plate, the hammer will also return to its initial position. So this was all about the functioning of the electric bell. Okay children, so let's move to the next question. If the current is passed through the coils, does the pin clings to the coil? So children, if we have if we pass the current through a coil, what will be produced? The magnetic effect of electric current will produce, and as a result it will start attracting or clinging the pins to it. Okay, but when we stop the current that is flowing through it, it will no longer attract the pins. Okay, let's move to the next question. Bujo made an electromagnet by winding 50 turns of wire over an iron screw. So what Bujo did is, he took an iron nail and he coiled or wind this wire around it, and he made 50 turns of it. Okay, then Paheli also made a similar electromagnet by winding 100 turns over a similar iron screw. She took a similar iron screw, but what she did different was, she made 100 turns of this wire. So children, which electromagnet will attract more pins? And we have discussed that the strength of an electromagnet depends upon the number of turns. More the number of turns, the greater will be the magnetic strength. So I am sure all of you can answer this, that this screw which Paheli made with 100 turns will definitely attract more pins. Okay, so children, the next question is, state the property of a conducting wire is utilized in making the electric fuse. So children, which property of the conducting wire is used to make an electric fuse? The property is heating effect of electric current. Heating effect of electric current. So children, we select the material of the wire which we use for making a fuse. We select it such a way that this wire has low melting point. So whenever excess current flows through it, it will become so hot, and it will reach its melting point, which is quite low, and it will quickly burn and it will break the circuit. And as a result, it will protect our appliances from getting damaged. Okay, so this was the principle of an electric fuse. So next question is, children, briefly state the effects of electricity. So children, we have discussed about two effects of electricity. The first effect that we studied was heating effect of electric current, and second effect that we studied was magnetic effect of electric current. So children, what is heating effect of electric current? So children, whenever the current flows through a wire, it will become heated, and this is the heating effect of electric current. And in our daily life where we can observe it in case of a bulb. If we switch it on for some time, say 5-10 minutes, then switch it off and try to touch it, what will happen? It will be hot. And this proves that we have heating effect of electric current. Then what is the magnetic effect of electric current, children? Whenever the current flows through a wire, what will happen? It will start behaving like a magnet. And we can verify this using a compass. And whenever the current will flow through this wire, there will be a deflection in the needle of the compass. This proves the magnetic effect of electric current. Okay, children? So the next question is, we should not touch the lighted bulb. Why? Because of the heating effect of electric current, children, right? Because whenever we light a bulb, the current is flowing through it, okay? And whenever the current flows through it, the heat is produced and it will become very hot. So children, also we should never cover the lighted bulb with any cloth, because after some time it will become so hot that it can even catch fire, okay? So we should never touch the lighted bulb, okay? Then the next question is, distinguish between an open circuit and a closed circuit. So children, what is an open circuit? Open circuit is one where we have switch in off position. That is, the circuit is open and in this case the current is not flowing through it, and we can say the switch will be in off position. Whereas in the closed circuit, the switch will be in on position and circuit will be complete. Okay, and the current will flow through such a circuit. So this was all about the open circuit and closed circuit. Okay. Then the next question, explain the following. Copper and aluminium wires are usually employed for electricity transmission. Explain the reason. So children, before selecting the wire for such a purpose for electrical appliance, for electricity transmission, we use copper and aluminium wires. Why? Because they are very good conductors of electricity. And whenever we use a good conductor of electricity, it will offer least resistance or obstruction to the flow of current, and there will be very small or almost negligible heat produced, okay? And it will not damage our circuit, nor it will damage the wires that we'll be using in the circuit for transmission of electric current, okay? Then the next question is, the tungsten is used almost exclusively for the filament of the electric lamp. Why? So children, we have a bulb and you can observe a thin wire in center of it, which is the filament of the bulb, okay? And it is made using tungsten. Why, children? Because tungsten has a special property of bearing very high temperatures. So when the current will flow through it, even so the heat produced by it is so large, children, that it will start glowing, but it will not break, okay? So this is the special property of the tungsten metal, and that is why it is used in case of a filament of the bulb, okay? Then the next question, children, the longer line in the symbol of the cell represents, so children, we have studied the cell is represented by a pair of parallel lines. The longer line represents the positive terminal of the cell, right? The next question is, the combination of two or more cells is called as a battery. Very good, children. Then the next question is, the current is switched on in a room heater. So children, whenever the current is switched on in the room heater, what will happen? It has a coil inside it, or the element, it will start heating and start to glow, or it will produce heat, okay? Then we have the safety device based on the heating effect of electric current is called as a fuse. Okay, children, so this was all about the question and answer session from the topics that we have covered so far. So thank you so much for your attention.